Hello and welcome to Rudy's Electronics Lab. Last year I reviewed a Siglent SDS1000X Plus signal generator, and in that review we talked about quite a lot of topics, but one of the things that we noted that even though it lost some performance characteristics compared to its predecessor, like the rise time on square waves, it did gain some interesting additional features. And I think the most important one, and that we also see prominently I think in Siglent marketing, is the pseudo-random bit sequence generator, the PRBS generator that can be used for testing telecommunication systems. I think here Siglent was a bit inspired, for example, by a rather similar looking Keysight device that also offered that possibility. Now, in my review last year, I also noted that this PRBS function did not seem to work properly. Actually, the codes, the patterns that was generating were not kind of recognized by any of the other industry standard devices that I got in the lab that use that type of patterns here. And there were even like 2 follow-up videos where, together with the input of viewers of my channel, we tried to look into what actually went wrong, why the Siglent device did not create the proper patterns in that mode. And we concluded in the end because it was kind of using the wrong polynomials. I refer you to this episode to get more into details. Last week, Siglent, after exactly 1 year after the original firmware release, came up with a new firmware release for this device. And in that new firmware release, they basically talk about having addressed this issue. And specifically, they are saying here that they modified the default output polynomial of the PRBS. So apparently they fixed it to the proper ones that are used in the industry. And also that they support now programmable polynomials, which actually support in some more expensive devices as well. So I thought it was kind of a nice idea to take this opportunity and see if everything works now properly. Siglent also came out with a bunch of other improvements in this firmware. If you take a close look at the most important ones, I would say it is about the screenshot mode that is improved. It can save both PNG and BPM formats now, and it's also saved directly to the USB thumb drive. And that's also something I commented on in my original review, is that it saves all the screen prints to the internal drive, and it takes like 10 or 15 times you have to push a button and turn a knob basically to get them on the USB stick. So if you do that for 10 screen prints in a row, it's getting rather cumbersome. So apparently this is addressed. On top of it, they talked about adding a step sweep mode. Now, could be interesting. Took a quick look at it. Not going to talk about it in this video. And they changed something about the DC mode, so the mode where it can deliver like a constant voltage out. And apparently there they fixed something that it doesn't always jump to 0 if you change the setting. But in this episode I want to focus really on the PRBS functionality and see if they got it right this time. Now let's go and take a look here. This is my measurement setup. We got the Siglent device here. We got a couple of other devices here. It might look a little bit intimidating with the little Siglent with all these huge devices here, but basically these are all other instruments that implement PRBS testing or in some cases also generating the signals. So we're mostly using them basically as testing, basically an incoming PRBS type of signal. So that's the Rohde & Schwarz SMIQ, it's the Anritsu MG3700A, it's a TTC Firebird. I think all of them have kind of features in previous episode. And I've also hooked up an oscilloscope here so we see how if the signals look proper that we want to analyze here today. So here we got the menu for it. The interface changed a little bit here, as you might see when you look to my earlier videos with the previous interface. They moved some settings here. PBRF settings, they moved the logic setting and the rise fall time, etc. And the differential part already existed in the previous version, but just moved. And here on PRBS Edit, basically you get the length of the polynomial and you can program your own polynomials. I'll get to that in a second. It's a bit Weird that I got a thing here to start and stop the code, because I don't see any use for it, and basically starting and stopping is also happening with this output here, so it kind of fully overlaps. You have to enable both. I would rather that I would have left this out and just have the length setting here right away on this, this page, and that it automatically starts a generator. There's always an additional step now in between. But anyway, we can live with that. So what I did is that I set it to generate PRBS 9 patterns, which are very common. I set it at a bit rate of 1 megahertz. I set all my receivers here also on the 9 length in order to look at them. And the oscilloscope is basically gonna pick up the code if everything goes well. And since I know that one of the features of the PRBS 9 code is that there always should be one instant of 9 values, one in a row, I basically choose the trigger width of 8.5 microseconds or more, because I got 1 megahertz here, so there's 1 microsecond per bit. So 8.5 microseconds should recognize something that is as long as 9 microseconds. This is also because we don't have a pattern clock out or something here, so we kind of to find out ourselves. Now let's power up and see whether my devices now recognize this particular code here. I'm starting it up, and what I'm seeing here, moving here, yes, my TTC now recognizes for the first time the code coming from the Siglent. I do get an error that it's the clock is inverted. I could move the clock by 180 degrees on my signal generator, but I don't really care. He corrects that automatically. It doesn't really matter where we pick it up in the sequence anyway. I mean, any clock time is fine as long as not just on the moment that the state is changing. So no worries there, works properly. Anritsu, yeah, you can see here in the slider here, hopefully going up and down. Anritsu properly picks it up here. And how about the SMIQ? It's also set to 9. And yes, we see here the values moving, no errors. So yes, finally we got a working 9 code out of the Siglent device. Now let's also try some other code length to see if everything is implemented properly. So I'm going to move to 20, which is another common code length, and that is also implemented on all the devices I got here. So let me move everything to 20 and restart the video. Okay, I'm back, and I set everything to PRBS 20. That means I set 20 default on my signal generator. The code length on all the receivers is set to 20, and I'm also picking up the code here, looking again at a string of 20 bits of 1. So actually I'm looking at more than 18 or 19 microseconds of a positive pulse width. We should be picking it up. So now go and start the generator. Generator is running. You can see it's being picked up by the scope. It's a much longer code, so it only repeats itself less often per second. So we see the scope sometimes picking it up. And do we recognize this code by any of the signal analyzers? No. None of the 3 of them is picking up the 20 type of code correctly. So something must have been going wrong here. Could it be my receivers that are not properly picking up a 20 code? Let me take a quick look, because I can also create a 20 code with my SMIQ. So I got the data bit here. I got the clock bit here. Yeah. And now everything is receiving a 20 code. So it seems that all my analyzers are set up properly, but somehow the Siglent is not creating the proper code. So let me go back here, data, bit clock. And I did this experiment with all the different PN codes I could decode. The Siglent can make a lot of different code lengths, but actually there are like 8 of them that are commonly implemented that I find on these devices. Not all of them support exactly the same sets, but all of them do kind of 9 and 11 and 15 and 20, and there are a couple of others that are only implemented by either this one or that one or so, that one. That's all fine, but altogether out of the 8 codes that I could test on any of my devices, half of them, 4 codes actually don't work on the Siglent. So now the big question is, why do half of the codes generated by the Siglent still do not work? And in order to answer that question, I want to play around a little bit with this possibility that we can now program our own polynomials, because maybe that's why they still got the wrong polynomials in their system. So let's go and give that a try right now. So moving to this menu here, we earlier saw here the menu where the default polynomials, and we can go to a manual setting here. And basically we can add and delete here. I can show you, we can say that tab number 12 polynomial must be added here. We'll leave it that way. We can also set the seed of the pattern. And setting the seed is a kind of an interesting feature in itself, because it's kind of a starting point for the algorithm to start making this code. But since we don't have a pattern clock out, the seed doesn't have any value. We never know kind of when the starting point is in our sequence. If we had a pattern sync out, then the seed kind of makes sense. Since we don't have that, any seed will work except 0. And actually you cannot put it on 0 here, which is kind of an okay thing. That's the only thing that doesn't get the whole thing started up. Any other seed code should work basically for, in this case, we are on 20, so the 20-bit register. What's also strange about the seed implementation that you can also put much higher values than the actual length of your shift register, which I think doesn't make any sense. So for me, they could have left the whole thing about the seed out. But anyway, it's there. But now let's look at trying to enter the polynomials and see how it's working. So I'm choosing here 2 polynomials, and I'm choosing now 17 and 20. The tabs. And why these? Because these are the proper tabs that we should have with the 20 length of code. How do I know? We find that in the official standard, the ITU 0151 series. But I also took a quick look at how other devices do it. And I've been looking, for example, at this keysight unit here, which seems to be a little bit of an inspiration perhaps for the Siglent. And in their manual, we can exactly see all the different PRBS polynomials that we're using. And we can see that for the 20 length, it is tab number 20 and tab number 17 that we should be taking. So I'm programming that right now into my Siglent. I'm going back into the menu. I'm starting the whole thing up again. And what do we see here? Yes, I see now that my TTC is accepting it. I see now that the SMIQ is properly recognizing, and I also see that my Anritsu is recognizing it. So yeah, again, they kind of programmed the wrong algorithm for half of the algorithm, half of the ones that I could test now, 4 out of 8. But if you kind of manually enter them, if you look at the documentation of, for example, a keysight device, take the numbers from that manual and type them themselves into your Siglent, you actually get the right ones. So yeah, I'm not terribly impressed yet by this firmware upgrade. It's nice to see that Siglent is responsive and has reacted to the comments that we've been making about having the right PBRS code, but kind of typing them wrong into the device again doesn't help us much. So I look forward of perhaps a future firmware upgrade, maybe a little bit sooner than after a year, where they would fix this PRBS code and maybe also address some of the other points that I brought up earlier, which included, for example, that for reasons I didn't understand, the startup time of the device doubled from about 20 to 40 seconds. And that's probably just a firmware thing that you can make it start again in 20 seconds like all the other devices in this series. And a bunch of other features and functionalities that would be nice to address in this device. So it's a nice thing they're still making firmware upgrades, but I think they should take a little bit more care and kind of fix the things now that they introduced with problems with this new firmware upgrade. That's it for today. Hoping to be making a new video soon. I'm very busy with my regular work, but I got some really great episodes in the planning here, but it will take me much more time to make. So hope to catch you off one of these future episodes, and see you then next time.